We'll now look at example 3. So example 3 is a follow-on from example 2. Most of the figures are the same, there's just one slight difference. So in this question we're asked what power can be transmitted by a steel propeller shaft 50 millimeters in diameter that has a 20 millimeter hole drilled through the center. So this is the difference between example 3 and example 2, the last example. The shaft still rotates at a speed of 300 RPM and the shear stress is limited to 90 megameters per meter squared. Right, so everything is the same from example 2 with the exception of this hole drilled through the center of the shaft. So when we looked at example 2, where we had a 50 millimeter solid shaft, we saw that we could transmit 69 kilowatts of power. In this example, we have drilled a 20 millimeter hole through the center of the shaft. So, proportionately a large hole in the shaft, and we're going to calculate how much power can be transmitted. Now, it's indicated here that the solution will be 67.6 kilowatts, which is not a big difference. Okay, so if this turns out to be the answer, we will see that the shaft can actually take a sizable hole in it without affecting the overall amount of power that can be transmitted by too much. Okay, so let's look at the solution. So I've copied in the formula that we use for torsion, and we have these values then in the question. So we have an outside diameter of 50 millimeters, an inside diameter of 20 millimeters, we have an RPM of 300, and we have a shear stress of 90 megameters per meter squared. So if I paste those values in, so there's the 50 and the 20, there's the 300, there's the 90 meganewtons. C here is the radius of the shaft, and the radius you use is the outside radius. So the shaft has an outside diameter of 50 millimeters, so the radius then is 25 millimeters. So that's 0.025 meters. Okay, let's put those values into our calculator and see how we get on. Okay, so the first thing we'll calculate is the second polar moment, and it is going to be pi multiplied by 0.05 4 minus 0.02 4 22. So that is 597 by 10 to the power minus 9. And if I round that up, that's 598. So I get 598 by 10 to the power 9 meters to the power 4. Okay, we want to get omega then. So omega is 300 multiplied by 2 multiplied by pi and divide that by 60. And that is 31.42 if you round that up. I can then take this J value and substitute it back in here. So the torque then just becomes J times this value. So torque is J times 90 meganewtons per meter squared divided by 0.025 meters. So if I put that into my calculator at 598 10 to the power minus 9 multiplied by 96 all over 0.025, and I get 2,152.8 Newton meters. If I want to get the power then, well, the power is torque times omega. So I'm going to multiply my 2152.8 Newton meters by 31.42 radians per second. gives me 67640 watts, which is essentially 67.6 kilowatts, which is the answer that we were expecting to get. So that's very interesting. You know, if we had a shaft, solid shaft, 50 millimeters in diameter, we saw we could transmit 69 kilowatts. And if we drilled the hole 20 millimeters inside that shaft, we could still transmit 67 kilowatts. So there hasn't been a huge degradation in the amount of power that the shaft transmits. Okay, so thanks for watching, and we'll come up with example 4